Hi, welcome. This is section 9.8 on page 111. And this it's a pretty nice section. We're just going to talk about symmetry. Symmetry is when, let me fix that a little bit. Symmetry is when a figure has line symmetry if the figure can be mapped onto itself by a reflection in a line. Think of like a mirror image. So right here, if I could cut this image in half, and I could fold it in half, and it would fall on top of itself like this. Now, if you think about people, like I as a person would have line symmetry if you cut me vertically. Pretty much you're going to be symmetrical as a person. But what if they cut me horizontally at my waist? Then I am not symmetrical that way. So I have one line of symmetry, and it would be a vertical line of symmetry. This triangle has one vertical line of symmetry. Sometimes things could have more than one line of symmetry, like a square. Different shapes would have more than one line of symmetry. This would have one line. I, as a human, would have one line. Point symmetry is a figure has point symmetry if the figure can be mapped onto itself by rotating the figure 180. Remember, 180 is one line, basically. Like half of a circle. Now, if you were to pick basically the center of gravity here, and the way to tell this, remember the patty paper I've shown you guys before, this patty paper? If I were to draw kind of this shape, trace it, and if I were to pick what I believe to be about the center of gravity, let's say it's about this piece right here. Now, if I think that's my center of gravity, can I rotate this 90 degrees? Does it fall back on top of itself? No. But what about 180? And it does at 180 degrees. So point symmetry is exactly 180 degrees. And it's rotating. So that's, because it's rotational symmetry still, it's rotational at 180 degrees. I don't usually hear people refer to it as point symmetry. Usually they refer to it as rotational symmetry. So this one here has rotational symmetry. I'm always interrupted by my kids. So the next one here is a sun. And I'm going to get a new piece of patty paper up here. Now, if I were to trace this, and pick about the center of gravity here. If I rotate it, look, it's going to fall on top of itself right there, and right there, and right there, a little bit off, and right there, and right there. It's going to keep falling back on top of itself all the way around like a little pinwheel. So this has rotational symmetry if the figure can be mapped onto itself rotating less than 360. Because if you think about it, absolutely everything, even if I go up to this triangle here, let's pick the center of gravity, about what we think it would be. If I rotate it, let's say 90, here it is. If I rotate it 180, look, it doesn't fall on itself. This does not have rotational symmetry. And if I go, that's 180, this is 270, and then 360, it does. Everything has 360. Like if you go one complete revolution, everything has 360 rotation. So we don't care about that. It has to be before 360. So because this has 1, 2, 3, 4, 5, 6, 7, 8 points where it's going to happen, I can take the 360 and divide it by 8. And I get 45. That means that every time it rotates from the center, this angle right here is going to be a 45-degree angle. So it rotates at 45 degrees, at 90 degrees, at, oh, I don't have my calculator. hand pause button. I love it. So here, 45, 90, 135, 180, 225, 270, 315, and then 360. And again, we don't care about 360 because 360 works for everything. So this has rotational symmetry at all of those angles. I don't think you need to know that. You may. It's a good piece. So what I want you to do is I want you to pause, take a moment, and check off every single one that you think counts. So there will be more than one. And then we'll draw what we think it is. So pause and check off all 8 of them, and then come back. Okay, so this one right here does have a line. I could draw lines, and let me do the lines in green. So I could draw a line straight down like this, and you see that it would reflect over itself. I could draw a line through any of the sides like this. Straight lines are they're perpendicular right in the center and they'll reflect. I could also draw lines, look, from the vertice to vertice. That would be another line. This one would create another line where it would reflect exactly in half. You could draw these on patty paper and fold them and see. And one more right here. So I have, if I want to count, I have 1, 2, 3, 4, 5, 6, and then look, this is the same one. So I have lines are reflection, and I have 6 lines of reflective symmetry. Okay, do I have rotational symmetry? So come back over here, and do I have rotational symmetry? And my center of gravity, if I rotate it, look, it's going to fall into itself right there, and right there. And if I want, I can kind of make a little plus sign right here, because then I see when it is before 90. It doesn't have rotational symmetry at 90, though. Look, it doesn't work when it's at 90. It was before 90. So what's going to happen is there are 6 sides. I'm going to take my 360, divide by 6, and I'm going to get 60. It's going to happen at 60 degrees, at 120 degrees. So we could write these down. I'm going to write them at the bottom. 60, 120, 180 it will work at, plus 60 will be 240, plus 60 will be 300, and then 360. Do we include 360? No, because that works for all of it. So those are my rotational symmetry. Now, point symmetry was specifically 180. So did it work at 180? And yes, it did. You can see right here, let's say we start right here. Not at 90, but at 180 right there, yep, it did land back on top of itself at 180. So 180 does work. So over here with the triangle, does it have line symmetry? It does have line symmetry through all of the vertices. So we can draw the line right here. And I can flip it this way and notice that it's going to reflect on itself here. And I notice it will reflect on itself right here. So it's going to have line symmetry. They should all intersect at the same point if I drew it correctly. So yes, we do have line symmetry. Now, does it have rotational symmetry? Let's see. So rotational symmetry here. And again, you can make a plus because then you can kind of see if it's 90 or not. Now, at 90, it has not turned on to itself yet. But notice that it does right here before 180. And then not, and then again one more time. So I'm going to take the 360 with the 3 points, divide by 3. I'm going to get 120. I have rotational symmetry at 120, add 120 to 240, add 120 to 360, and again we don't count 360. So this one has rotational symmetry, but it does not have point symmetry because it doesn't have 180. So that's what's really important here. Okay, so here, it does not have line symmetry. You cannot draw a line. Notice that if you drew a line here, and again, if you want to use your patty paper, I made a ton of these earlier to play with. Let's say, where do we think? Do we think it would have line symmetry this way? Well, if I were to fold it in half through those vertices, you can see that it doesn't fall right on top of itself. Okay, what if I draw it straight down like this? Well, let's say I fold it in half this way. You can see it, again, it is not going to fall on top of itself. And as you can see through that patty paper, this does not have line symmetry. It does have rotational symmetry. I can come back here and rotate. Rotate 90, nothing. 180. It has it at exactly 180. So it does have rotational, but because it is 180, it is definitely point. But point is not one we use common, like common, very commonly. That sounds wrong to me. It's not one that we use very often. Generally, we could just say rotational at 180. You don't have to say point. But for some reason, this book does. Over here, is there a line? There is no line that it will reflect on. Does it have point? If it rotates, it's not going to fall on top of itself ever. So it definitely doesn't have point. It has none of them. This one here, I definitely have line symmetry. I could draw line symmetry through all of the star vertices. Notice that that would fold right on top of itself. And it's going to happen in all of the points. And if I do that at all of the points, how many did I have? 1, 2, 3, 4, 5. I end up with 5 lines of symmetry here. Okay, do I have rotational symmetry? Well, yeah, it's going to rotate at, because there's 5 points, you can use your patty paper, and it's regular, it's going to be every 5. So I can take 360 here, divide by 5, 7, 35, 72 degrees. So if I do 72 plus 72, I get 144, 216, 288, and then 360. Remember, we do not count 360, so it has rotational symmetry. So here it had line symmetry, it had rotational symmetry. It doesn't have the point. No, it does not have 180, so it doesn't have the point. Now this one over here, a little bit crazy, there does not appear to be, if I drew a line this way, would it reflect exactly on itself? No, those little squiggle things would not match up. So it does not have line symmetry. You can use a patty paper if you want to check this. I would draw a little line right there. I draw that line so I know when it turns 90. So at 90, no. At 180, look, at 180 it does. So it does have rotational at exactly 180. So it has point. And then 270, and then again on itself at 360. Okay, A over here. What does it have? you could draw a line down the middle here. And it will have line symmetry, only one of them. If it rotates, 90, 180 would be upside down. It would only work at 360, so it does not have rotational or point. This one, no line. Point, at 180 it would be upside, it would only work at 360. So again, those are not going to work. This would be none. No lines of symmetry. No symmetry at all. Okay, so I'm going to pause and go to the next page. Okay, so on this second page, I'm going to pause and I'm going to come through and I'm going to answer all of them. So I want you to pause and I want you to do all, what is there, 10 of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do all 12 of these and then come back and check to see my answers. I think my camera's messed up in the corner now. Anyway, I'm going to pause, come back and check all of them and see if you got them right or not. So as I went through, I highlighted the answers and I tried to go through and either write the angles that worked or draw the lines also that were symmetrical. So this one was at 90, 180, 270, not 360 because it's for everything, doesn't count. No lines that would fold on. This one would fold this way, horizontally or vertically, so 2 lines. And only at 180 would it work. None, this one only had a line. It would not fold on top of itself horizontally. And if it rotates, it would have different angle measures on top and bottom. So the rotation would not work here either. Use patty paper if you don't believe me, but that one's a little tricky. Like it's an eye trick. This one had 3 lines, rotates at the 3 points, 120 and 240. This one was at just 180. So I didn't put this one, but it's 180 degrees only. This one down here had the 2 pink lines and the 2 green lines, so 4 lines, and it rotated at 90, 180, 270. This one, only 1 complete flip of 180. This was none. This one had a line, but that was it. This one had just rotational 3 times, so 360 divided by 3 was 120 and 240. This one had 3 green lines and 3 pink lines through the middles, so 6 lines altogether, and there were 6 points of the turn, so divided we'd get 60, 120, 180, 240, and 300. So that is our symmetry. Anyway, that's it for the notes. Have a fabulous day, and I'll see you next time.